Tesla's future may depend on a single piece of technology, and that tiny piece of silicon could determine how quickly the company reaches unsupervised full self-driving, expands its robotaxi network, and turns the next generation of Optimus into a truly capable humanoid machine. Imagine a computer chip small enough to fit inside your hand, yet powerful enough to influence how millions of vehicles drive themselves and how thousands of robots understand the world around them. That's the promise behind Tesla's next-generation AI5 processor. And now, the development of this chip is entering a critical stage, with Samsung reportedly preparing production using advanced semiconductor technology in Texas. If everything goes according to Tesla's plans, AI5 could become one of the most important pieces of hardware the company has ever developed. According to reports surrounding Samsung Foundry, Tesla's AI5 design has completed tape-out, meaning the chip design has reached an important stage before manufacturing. Samsung is expected to produce versions of the processor at its Taylor, Texas facility using an advanced 2-nanometer manufacturing process. That is a major development, because AI5 isn't being designed for just one product. The same computing architecture could eventually support Tesla vehicles, autonomous driving systems, robotaxis, and Optimus humanoid robots. Tesla's approach to AI hardware has always been different from the traditional automotive industry. Instead of depending entirely on third-party processors, Tesla has spent years designing its own hardware and software together. Companies such as Waymo and Cruise have relied heavily on specialized computing platforms, including hardware from NVIDIA, combined with their own software systems. Tesla chose another path. The company wanted to control the entire stack, from cameras and sensors to neural networks, inference hardware, and the software that interprets everything happening around the vehicle. AI5 represents the next major step in that strategy. Elon Musk has previously suggested that a single AI5 chip could deliver several times the useful computing performance of the dual AI4 configuration currently used in Tesla vehicles. The theoretical improvements are even more dramatic when looking at individual specifications. AI5 is expected to provide substantially more computing power, significantly more memory, and much greater memory bandwidth than the previous generation. Some estimates place its performance in the range of thousands of TOPS, or trillions of operations per second. Compared with the computing capability available in Tesla's existing AI4 hardware, that's a massive jump. But raw TOPS numbers don't tell the entire story. The real advantage of AI5 could come from how efficiently Tesla has designed the processor to handle the specific workloads generated by its neural networks. Think about what Tesla's full self-driving system has to process every second. The vehicle is constantly receiving information from multiple cameras and sensors. It has to identify pedestrians, vehicles, traffic lights, road markings, signs, intersections, obstacles, and countless other objects. At the same time, it needs to predict what those objects are likely to do next and determine how the vehicle should respond. AI4 has already allowed Tesla to make significant progress in this area. But AI4 still has computational limitations. Larger AI models require more memory. More sophisticated perception systems require greater bandwidth. And increasingly complex decision-making requires faster inference. AI5 is being designed specifically to push beyond those limitations. Tesla has also been working to optimize its hardware at the silicon level so that workloads that previously required multiple computational steps can be executed much more efficiently. That could dramatically reduce latency. And when you're talking about autonomous driving or humanoid robots, latency isn't just a technical specification. It can determine whether a machine reacts in time. Consider a vehicle approaching a busy intersection. A pedestrian suddenly moves toward the road. Another vehicle changes lanes. A cyclist appears from behind an obstacle. The AI system has to process all of those events almost simultaneously. If the computer needs too much time to analyze the information, the vehicle's response could be delayed. AI5 is intended to give Tesla significantly more computational headroom, so its neural networks can process these situations faster and with greater complexity. And one of the most interesting parts of the AI5 story is where Tesla plans to manufacture it. Samsung's Taylor Semiconductor facility in Texas is located relatively close to Tesla's Gigafactory Texas. That geographic connection could become strategically important. Instead of relying entirely on semiconductor production thousands of miles away, Tesla could have a major chip manufacturing partner operating inside the United States and relatively close to one of its most important vehicle and robotics factories. Samsung is reportedly preparing to manufacture AI5 using an advanced 2-nanometer process. That is significant because smaller semiconductor process nodes can potentially deliver higher performance while improving energy efficiency. For Tesla, that matters enormously. Every watt consumed by a vehicle's computer ultimately affects energy efficiency. And for Optimus, the importance is even greater because the robot has to carry its own computing hardware and battery. A heavier computer means a heavier robot. A heavier robot requires more energy. And more energy consumption can reduce operating time. So Tesla needs AI hardware that is not only powerful, but extremely efficient. Tesla is also reportedly pursuing multiple manufacturing sources for its future chips. Samsung could produce AI5 chips in the United States, while TSMC may provide additional capacity. That strategy would give Tesla greater flexibility if demand increases dramatically. And demand could become enormous. Tesla isn't developing AI5 simply for a few thousand vehicles. The long-term goal is much larger. Millions of vehicles could eventually require increasingly powerful onboard computers. Then there is the robotaxi opportunity. Tesla's Cybercab program could become one of the biggest beneficiaries of AI5. A robotaxi doesn't have the luxury of depending on a human driver to correct mistakes. The computer has to understand the environment, make decisions, and control the vehicle continuously. The more capable the onboard processor becomes, the more sophisticated the autonomous driving system can potentially become. And if Tesla eventually operates hundreds of thousands or even millions of autonomous vehicles, computational efficiency becomes an enormous economic factor. Every vehicle would need to process data continuously. Every additional watt of computing power has consequences for energy consumption. Every additional second spent charging represents time the vehicle isn't carrying passengers. And every autonomous mile could potentially generate revenue. That's why Tesla's AI hardware strategy is about much more than making a faster computer. It's about creating an entire economic platform around autonomous transportation. Imagine a fleet of cybercabs operating almost continuously. Passengers request rides through an app. The vehicle drives to the passenger without a human driver. It completes the trip, drops the passenger off, and immediately accepts another ride. The vehicle can continue operating throughout the day and potentially throughout the night. In that environment, the cost of computing, energy, maintenance, and charging becomes critically important. The more efficient Tesla can make every part of that system, the stronger the business case becomes. But AI5 isn't only about cars. Optimus could be an even more interesting application. A humanoid robot has a completely different problem from a vehicle. A car primarily moves through an environment. A robot has to physically interact with that environment. It needs to pick objects up. It needs to walk. It needs to balance. It needs to move its fingers. It needs to understand what is happening around its body. And it needs to coordinate dozens of moving joints simultaneously. That's why computing latency becomes incredibly important. Imagine Optimus carrying a heavy container through a factory. Suddenly, A worker steps into its path. The robot can't simply recognize the person. It needs to estimate their movement, determine whether collision is possible, calculate a new trajectory, adjust its balance, and safely change direction. All of that has to happen extremely quickly. A delay of a few hundred milliseconds could make the difference between smooth movement and an awkward stop. This is where AI5 could become extremely valuable. Higher memory bandwidth means information from cameras and sensors can be delivered to the processor faster. More computational capacity means larger and more sophisticated neural networks can run locally. Lower latency means the robot can react to changes in its surroundings much more quickly. Instead of behaving like a machine following a rigid sequence of commands, Optimus could increasingly behave like an adaptive system. And that is ultimately Tesla's vision. The goal isn't simply to build a robot that repeats the same movement over and over. The goal is to create a machine that can operate in environments that were designed for humans. Think about a factory. A box might not be placed in exactly the same location every time. A tool could be moved. A worker might walk into the robot's workspace. A shipment could arrive late. A production line could change. Traditional automation works extremely well when the environment is predictable. But programming a conventional machine for every possible variation can become expensive and time-consuming. Humanoid robots offer a different possibility. Instead of designing a specialized machine for every individual task, Tesla wants Optimus to learn how humans perform tasks, and then adapt those skills to changing environments. That could make automation economically viable for tasks that previously weren't worth automating. And AI5 could provide the computational foundation needed to make that vision practical. Tesla has already demonstrated increasingly advanced Optimus capabilities. The robot has become faster. Its walking motion has become smoother. Its balance has improved. Its hands have become more capable. And its ability to interact with objects has continued to advance. But mechanical improvements alone aren't enough. The robot also needs a powerful brain. That's where AI5 enters the picture. Musk has indicated that Tesla's future AI hardware will be shared across vehicles and humanoid robots, while later generations could place an even stronger emphasis on Optimus and Tesla's AI infrastructure. This is part of a much larger strategy. Tesla is effectively trying to build a common AI platform that can power multiple products. The same fundamental technology can potentially teach a car how to understand a road and teach a robot how to understand a factory. The physical hardware may be completely different, but the underlying intelligence can share similar principles. And this is one reason Tesla is investing so aggressively in custom silicon. If Tesla depended entirely on third-party hardware, it would have less control over performance, power consumption, cost, and production capacity. By designing its own processors, Tesla can optimize the hardware around the exact neural networks its engineers are developing. That vertical integration could become one of Tesla's biggest advantages if the company manages to execute successfully. Of course, there are still major challenges. Producing advanced 2-nanometer chips at high volume isn't easy. The manufacturing process has to achieve acceptable yields. A tiny defect can make an expensive chip unusable. And even if the hardware works perfectly, Tesla still has to develop AI models capable of taking advantage of all that computing power. More processing power doesn't automatically create autonomous driving. The software still has to understand the world correctly. The neural networks have to be trained. The data has to be processed. And the system has to be tested under an enormous range of real-world conditions. That's why Tesla's existing fleet is so important. Every vehicle already operating on the road can potentially provide valuable real-world driving information. Over time, that data can help Tesla train and improve its neural networks. By the time AI5 becomes widely available, Tesla could have accumulated an enormous amount of additional driving experience. That combination of hardware, software, and data is what Tesla believes can create a powerful competitive advantage. And the competition isn't standing still. NVIDIA continues to dominate the AI hardware industry. Other automakers are developing their own autonomous driving systems. Robot manufacturers are rapidly improving their humanoid platforms. Chinese robotics companies are also moving extremely quickly. So Tesla has little room for error. But if AI5 performs as expected, it could significantly increase Tesla's ability to scale its AI ambitions. A more powerful computer could enable more capable autonomous vehicles. More capable autonomous vehicles could enable a larger robotaxi network. And the same computing architecture could help Optimus become more intelligent, more responsive, and more useful. That's why this tiny chip could have such enormous consequences. For years, people have debated whether Tesla's promises about autonomous driving and humanoid robots are realistic. AI5 won't magically answer those questions. But it could provide the computing foundation Tesla believes it needs to move much closer to those goals. Industry expectations currently point toward engineering samples and early production phases before broader integration into future Tesla products. The exact timeline remains dependent on manufacturing, software development, validation, and Tesla's ability to scale production. Until the chips are actually deployed in large numbers, many of the performance claims should still be viewed as targets rather than guaranteed results. But one thing is becoming increasingly clear. Tesla is no longer treating artificial intelligence as a supporting feature for its cars. AI is becoming the center of the entire company. Vehicles are becoming AI platforms. Robotaxis could become autonomous mobility platforms. And Optimus could eventually become a physical AI platform capable of performing tasks in the real world. At the center of all of this is computing power. And AI5 may be one of the most important steps Tesla has taken toward building that future. The real question isn't whether AI5 is simply faster than AI4. The bigger question is what Tesla will actually do with all that additional intelligence. Because if AI5 performs anywhere near the levels Tesla is targeting, the next generation of Tesla vehicles and Optimus robots could look very different from the machines we are seeing today. And that is why the development of one tiny chip could ultimately determine how quickly Tesla's biggest futuristic ambitions become reality. What do you think about Tesla's AI5 chip and its potential impact on full self-driving, Cybercab, and Optimus? Do you think AI5 could finally give Tesla the computing power it needs to achieve truly autonomous vehicles and highly capable humanoid robots? Let us know your thoughts in the comments below. If you enjoyed this deep dive into Tesla's latest technology and want to stay updated on Optimus, AI5, Cybercab, and the future of electric vehicles, make sure to like this video, subscribe to the channel, and turn on the notification bell so you don't miss our next update. Thanks so much for watching and for supporting the channel. We really appreciate it. We'll see you in the next video. Until then, take care and stay safe.